Okay, page 454. I kind of mentioned adding and subtracting the other day. So, you guys remember what I said about it?
No.
I have to have a translation.
You can only add.
Yeah, you can only add and subtract like terms. So, you guys are starting. So, the same square roots would be the like terms. So this is kind of like the problem. What's 2x plus 3x? 5x. So it's kind of like that problem. What's 2 squared root of 5 plus 3 squared root of 5? 5 times square root of 5. That's how it works. Okay, what do you think would happen if I put 2 squared root of 5 plus 3 squared root of 6?
You can't do anything else.
Can't do it, doesn't simplify. Let's see, are there any of those? No. Everything on this page looks like you can do at least something, but you can only add and subtract like terms. So some of the problems are going to be more like, let's do this. This doesn't look like you can do anything right now, but any ideas?
There's a little tree thing.
Right, simplify the square root of 20. Now, square root of 5, that doesn't simplify, but what can I do with square root of 20?
5 and 4.
2 square root of 5, right?
Yes.
So now it turns into 2 square root of 5 minus 6 square root of 5, which would be negative 4 square root of 5. Okay, remember when the numbers are right next to this radical, that means times. Okay? The reason we don't actually multiply is because it'd be a giant messy decimal, so we just normally leave it like this. Sometimes a book might say what's, depending on the situation, might actually want the decimal. Like if you're trying to say how long should we measure it out on the field, you want the decimal version of that. Anyways, okay, let's start with number 1. Page 454, 1 through 20. I think I'm going to make 22 a bonus. We'll make 22 bonus. All right. Number 1, this might go kind of quickly. What do you guys think square root of 3 plus 5 square root of 3 is?
6 square root of 3.
Right, if there's no number in front of the square root of 3, what number's probably up there? 1 square root of 3. So 1 square root of 3 plus 5 square root of 3 is 6 square root of 3. Okay, number 3. Which of those 3 terms can we actually add together? The 2 square root of 3's. So what's 1 square root of 3 plus 1 square root of 3?
2 square root of 3.
Right, 1 square root of 3 plus 1 square root of 3 is 2 square root of 3. What are we going to do with that 4 square root of 2?
Leave it.
Just, tack it on there. Plus 4 square root of 2. Does the order matter that I wrote those 2 things in?
No.
No. Order of addition does not matter. Square root of 8 plus 3 square root of 2. That doesn't seem to add together, but
You can
simplify square root of 8. This is why we simplify numbers like square root of 8, because a lot of times they actually can add together with other square roots. Square root of 8 becomes what? What's square root of 8 become?
2 square root of 2.
2 square root of 2. So we have 2 square root of 2 plus 3 square root of 2 is,
5
I'll write it down here. 2 square root of 2 plus 3 square root of 2 is 5 square root of 2. 7. 5 square root of 12 minus 6 square root of 3. Do either of those square roots simplify?
12.
The 12. Because what can go into 12? 3 and 4, 4 and 3. Okay, actually I'm not sure we've done something quite like this yet. Square root of 12 becomes what?
2 squared root of 3.
2 squared of 3. But what about that 5 that's sticking out in front of it?
Add it. Add it to the 2.
What did I
Multiply it to the 2.
Yeah, what did I say was happening between the 5 and square root of 12? Multiply. So it's 5 times 2 squared root of 3, which is, guess what? 10 squared root of 3. Minus 6 squared root of 3, which is 4 squared root of 3. Not too bad, is it? Hopefully not. Number 9. Square root of 8. We simplified square root of 8 on number 5, so we can kind of cheat and steal that answer. You guys remember what square root of 8 changed into? 2 square root of 2. So I don't really need to redo it. I can just kind of write 2 square root of 2 right there. 2 square root of 2 plus 3 square root of 2 minus 4 square root of 2. So these are all like terms. So what's 2 plus 3 minus 4? 1. So what am I going to put for my answer? Just square root of 2. No, just square root of 2. I thought you said 2 square root of 2. 2 plus 3 minus 4 is just 1. 1 square root of 2 is just a square root of 2. You want to sing the rest of it, Xander?
Yes.
I'll set you up. You can tear it down.
Alright, let's go. Tear it down.
Cube root of 54. Okay. We're in the cube root zone. 54 is kind of a big number, so I'm guessing its cube root's going to simplify. What can go into 54?
6 and 9.
6 and 9. 2 and 3, 3 and 3. So what's that going to become?
3 square root of 2.
3 cube root of 2.
Oh, yeah.
So we got to take a triple out. So there's a triple 3 comes out. So it's 3 cube root of 2. 2's left over. I kind of forgot what the rest of the problem said. Minus or plus 5 cube root of 2. Okay. I kind of didn't mention this earlier, but do you guys think that like cube root of 2 plus square root of 2, would these two add together?
Nope.
No, they would not. These are two totally different numbers. So no, they don't add together. Anyway, but these are both cube roots, of course. So what would this be? 8 cube root of 2.
Oh, I'm sore.
Okay, 13. Oh, we're in the table. Okay, they're trying to make a point of this table. We'll look at it in a second. So for the first part, you don't have to make the table, just like list out what would go in the blanks. So what, x is 25, y is 44. What's the square root of x? So what's
5.
square root of 25 is 5. And then the square root of y, what's the square root of 144?
12.
12. You guys remember your 12s? And then, so the next question is, what would the square root of x plus the square root of y be?
17.
Right. This was the square root of x, this was the square root of y. So when we add them together, we would get 17. But the next thing says, what's the square root of it's different. It's not the square root of 25 plus the square root of 144. On this one, you do 25 plus 144, and then you take the square root of that at the end. So it's kind of like this in parentheses here. So 25 plus 144 is like 169. So what's the square root of 169?
13.
13. Okay, so they're just trying to point out that adding square roots individually is different than adding the numbers together and taking the square root of the whole thing. I believe that's the point they're trying to make with this table. 15, okay. What is the square root of 45? They weren't as nice on this one. Okay, 45 doesn't have a nice square root, but what goes into 45?
5 and 9.
5 and 9, so it's going to become 3 square root of 5. Okay, the next one is square root of 75. And what goes into 75? How many quarters and 75 cents? 3. And 25. So it's going to become
5
5 square root of 3. Kind of opposite them. Lost my place. So what's the square root of, what's this plus this, basically? Square root of x plus square root of y is, what's that plus that?
A square root of 3.
No.
Wait, what? A, oh.
Does not simplify.
Doesn't simplify, yeah.
So I just rewrote it. You guys get it?
Yeah.
One's a square root of 5, the other's a square root of 3. They don't mix well. Alright, and then the last one is what's the square root of x plus y. So if we add the x plus y together first, 45 plus 75 is 120. And let's see, what goes into 120? 10 and 12. I think there's only one double in that. So it's 2 square root of 5 times 2, 10 times 3, 30. 2 square root of 30. Okay, let's go ahead and look at 16 because, yeah.
Is it hard?
Well, I don't know. Based on the results of 13 through 15, we just did 13 and 15, what conclusion can you draw about the expression square root of x plus square root of y and square root of x plus y? So, like, they're saying, like, how do these two things compare? 2, 30. 5 times 2 times 3. How do these two compare? Are they the same thing?
I don't know.
No, they were different. Those two were different, those two were different. They're basically always different. Alright, so I think they just put they're not equal or something. What did they write? Yeah, they put they're not equal. It matters whether you do the square root first or whether you add first. It changes the answer. Okay, 17, more of the same. I think it's in the B section because there's more simplifying to do than normal. Also 19 is cubed roots. Okay, square root of 20. I feel like we did that one. Or did we? Maybe I'm thinking of my example. Oh no, number 6. That's
2 square root of 5.
Yeah, you guys remember square root of 20 was 2 square root of 5? So we got square root of 5 plus 2 square root of 5 minus, okay, we need to do 72, right? What goes into 72? 8 and 9. So that's, we got a couple doubles on this one. Oh, double 2, and a double 3. So what comes out?
Triple
6. We don't
I know.
care about triples. 2 times 3 comes out, so 6 square root of 2. And what else can I do on 17 there?
I add 5s.
Yeah, the first two terms go together. Square root of 5 plus 2 square root of 5 is 3 square root of 5s. And then we'll just keep that guy right there. We switch to cube roots, which means our calculators cannot save us. Alright, what goes into 16, 18? What goes into 16?
82.
8 actually has a cube root because see that. Get some good pictures.
Yes.
Really? What?
What is this?
I think
Good.
Say what?
They let like 12-year-olds do a trick on me.
I don't like it because the little kid.
Oh, it can't.
That little NFT kid.
Anyway, so we have triple 2, so it's 2 cubed root and a leftover 2. 2 cubed root of 2. Plus or minus? Plus. What goes into 18?
9 and 2.
It's kind of a weird one.
I'll get 3.
No triples. What does that mean?
That's the fun thing.
Doesn't do anything, so you didn't do much on that one. Now, technically, we did change the first term a little bit, but yeah, that's it.
Oh, was that 19?
Yeah.
We're
Oh, that's right, that's right.
Oh, we're.
I said 22 is bonus, didn't I? Should we do 21?
No.
Ooh.
Sure, no. Please.
Alright, since I wrote down, and a lot of people are gone too. So since I wrote down 20, we'll stick with that.
Who's running?
Yep. Yep.
Can you put me off in that?
So if you want to try 22 for bonus, you can. Reagan, let me go back to number 1 here.
I think it's all about.
Let's see. Stop
Here's
on.
my example yesterday.
Let me